sorry, G inverse. So that means that G inverse, okay, what's G of x for this particular problem? X cubed. Okay, so what I'm doing there is I'm replacing G of x with x cubed. Now I need to plug x cubed into the inverse function, right? So everywhere I see x, I replace that x with x cubed. So this becomes the cube root of what? The cube root of? What am I plugging in? X cubed. Right? This x cubed is going in right here, right there. And when you take the cube root of x cubed, we did this many different ways in the beginning of class, but that's the same as that. That's the same as just x to the 1, that's just x. And that I verified the first thing. Do y'all see this is building off of what we did last time with composition? Like you have to be comfortable with composition or else this isn't happening. All right? Are we done? That's one of two things I have to show, right? The next thing I have to show is that it works the other way around. All right, let's do it. So we want to show that. So instead of writing want to show, I'll put WTS. Want to show. Believe it or not, that's what mathematicians use. We actually write WTS. It's not just me being that lazy. That's what mathematicians actually use in papers. Want to show. All right, so I want to show what? This time if I take G and inside of it I put G inverse of x, that this will come out to be what? X. So I'm kind of reversing the order of things. So I take G and inside of it goes what? Cube root of x. And now what does G do to this? If I take that and plug it in here for this x, I'm supposed to cube it, right? So if you take the cube root of x and you cube it, you just get x, which is true. Who has a question? You all right? Okay. I'm going to give you two more functions. I want us to verify that these are inverses. There they are. F of x equals 1 over x minus 1. And then f inverse of x, I'm telling you, is 1 over x plus 1. Verify that these are inverses. So it's like somebody's telling you these are inverses, and you're skeptical, right? You're like, I don't know if I believe you. So you're going to check. So the first thing we're going to do, I want to show that when I take the inverse function and plug into it the original function, I should get x, right? I better get x. Let me do that work over here. All right, I'm going to take f inverse, and inside of it, what am I plugging in? 1 over x minus 1. Right? So this piece right here is being plugged into, what, the inverse function? Right there? Which means it's being plugged in right there. Be real careful. Look at that. That's going to be a little weird, isn't it? Because you're going to have 1 over what? 1 over all that, right? So this is going to become 1 over x minus 1. So that's you replacing that x with 1 over x minus 1, then you still have outside of this what? Plus 1. This better turn out to be x. And it does, because what's 1 over a fraction? It's just the reciprocal. Look, if we do 1 over 1/2, what's your answer? 2. Just flips. If you do 1 over 2/5, what's your answer? 5/2. It just flips the fraction on the bottom over. You can check that yourself. Right? I mean, this is the same as 1 divided by 1/2, and then we're going back to old school 1, keep dot flip, all that. Like, yes? Yeah? 1 divided by 2/5 is the same as 1 times 5 over 2. This is 5/2. All right, so that becomes what? This whole thing becomes what? X minus 1, and then you have what? Plus 1, and that's just x. That's good. That's what it needed to be, right? Are we done? No. Second thing, I want to show that when you do f, and then inside of that you put the inverse, right? Reverse the order. That when you do that, you still get x. If it works one way but not the other, then they're not inverses. It's got to work both ways. All right, so now I'm going to check that. So to check that, I do f. Inside of that, I do the inverse, right? Which is 1 over x plus 1. And now I'm taking that one, this right here, composition, I'm plugging that into f for that x right there, right? For that x right there. So I get 1 over what? So 1 over, what goes here? 1 over x plus 1, right? That's right there. So we did 1 over x plus 1 goes right there. And then we still have next to it, minus 1. And do you see what happens on the bottom? Yep. You get plus 1, minus 1. Those go away. You just get 1 over x. And then we just said that this is just going to be that flipped, and that's just x, and that checks. So these are indeed inverses of one another. Okay, well that's great. If somebody gives us a function, right, and then they give us the inverse, we can check to make sure that it's legitimate, right? But what if you just have a function and you want to find the inverse, right? That seems more practical, doesn't it? Like somebody gives you a function, you're like, hey, can I find its inverse? Can we do it, right? And there is a step, there's a procedure for this, all right? So in the notes here, the next topic here is, it says, find the inverse of a function. How to find the inverse of a function defined by an equation. There's a set of steps here. I'm going to go through these steps, but I'm not going to write them on the board. All right, so I'm going to leave them up here, but I'm just going to talk my way through them on the board, right? So let's take this example right here. All right, if y equals, I'm going to make up my own, 2, no, that's the one that's there. Let's go negative 5/3 plus 2. I'm giving that to you, right? What is that? If I ask you to graph that, what is that? It's a linear equation, right? So that should be a line, right? That should be a line. If you draw a line, is it a function? So it passes the vertical line test. Would a line pass the horizontal line test? Should, right? So this is a one-to-one function, right? So because I know this is a line, I know that I can rewrite this, right? Oops. That this would be a one-to-one function. right? It's a one-to-one function. I know that for sure because it's linear. So all I did here was replace the y with f of x. Anyone disagree that that we could refer to that as a function that we know it's one-to-one? Understand that? No? You question? You're okay? Okay, now the question is, if it's one-to-one, then what's its inverse? How do we find it? How do we find the inverse? So here's the steps, right? The first step, what I'm doing here is I'm finding the inverse. The first step is take your function and replace f of x with y. Basically take it back to where it came from here. Just rewrite that. Y equals negative 5x plus 2. Right, that's your first step. Then it says interchange, I'm still in step 1, interchange the variables x and y. So all that means is everywhere that you see a y, put an x. Everywhere you see an x, put a y. Just switch what they are. So where this y used to be, put x. Where this x used to be, put y. Now the reason you're doing that is because, remember, the inverse function takes things back to where they came from, right? So whatever this y is, the inverse needs to take that y back to x, and whatever this x is would need to go back to y. Like they switch places. So you do that, and then, if possible, this is step 2 now, if possible, solve the equation for y. So now I'm going to solve for y in that equation. Can you solve that for y? How would you solve this for y? If I told you to get y by itself, what would you do first? Sure. Subtract 2, right? Subtract 2 on both sides. And then divide by negative 5. And when I divide by negative 5 on both sides, I could write it this way. The whole thing over negative 5. Right? I could do that. And it says if you can solve for y, okay? If you can solve for y, which we did, right? We solved for y. This is the inverse then. That's what it's saying. This right here is the inverse. So this means, since we solved for y, that the inverse of that function is this side right here. X minus 2 over negative 5. Guaranteed. Now, step 3 says to do what? Check your answer. Like if you don't trust it, right, then we should check, right, to see did that work. And since this is our first example, let's check it, all right? Let's actually check to see if this is indeed the inverse of that function. How do we check to see if these are inverses? 2 things, right? We have 2 things we have to do. We have to show that when you do that into this, you get x, and then we have to show that when you do that into this, you get x. The 2 things we just did in the previous examples. So step 3, I'm going to check. First thing I want to show is that when I do the inverse and inside of it I put f, I better get x. So that means when I take the inverse function and I plug in f, what's f for us? Negative 5x plus 2. That when I do that, let's see, what happens if you take this right here, plug it into the inverse function for x? That means you're going to put it right there, aren't you? Taking that, going into the inverses means put it right there. So we get negative 5x plus 2, right? And then what? That's right there. Then what? Minus 2, and then over negative 5. And these 2's cancel, and you get negative 5x over negative 5, and that's x. And that's what we were hoping to see, right? Do you see how if you're a little shaky with composition still, it's gonna be a little weird, a little hard? Next. We're not done, right? Step 2 for checking. For step 2, we want to show that when you take f and plug the inverse into f, they kill each other off and you just get x. So this time I have f. Inside of it goes what? The inverse, x minus 2 over negative 5. Right? So this piece right here is getting plugged into f. So it's going in right there for that x right there. So we have negative 5 and then x, but x is this. So I'm going to put it in parentheses. It's x minus 2 over negative 5. What's still there? I'm not done, right? That's negative 5. This was the x, right? Negative 5x, and then what? Plus 2 still. Okay, just make sure you do your order of operations here, right? What happens first? Negative 5s cancel. Good. Those go away. And when those cancel, now you have the x minus 2, and now the plus 2. And then the 2's cancel, and you get x. Check. All right. Pardon?
I said not that was 9 to the 15th power.
Yeah, now we need to do something more complicated, all right? So let's look at this next one. Please pay attention to this problem. This is a problem that I like to put on tests. This one right here, something like it, all right? So I want us to find the inverse of f of x equals 2x plus 1 over x minus 1. Can anybody here tell me what type of function that is? Rational. We graphed rational functions, didn't we? Remember what rational functions look like? Vertical asymptotes, horizontal asymptotes, all that stuff is a pain in the ass. We are not sure right now if this is one-to-one. We actually don't know that, okay? But we are still going to try and see if it has an inverse. All right? We are going to see if it does. We could verify by graphing this whether or not it's one-to-one, checking the horizontal line test. Y'all want to see? We can do it on the computer real quick if you want, just to kind of verify. If we have the computer graph 2x plus 1 over x minus 1, there's the graph right there. Does that look like it's a function that it passes both the vertical and horizontal line tests? Yeah? So it should have an inverse. Let's find the inverse. Also, while I have it there, I'm going to go ahead and graph y equals x, which is the identity function, right? If we get an answer here, right, when we get an answer here, when we graph that answer, it should be a reflection over that axis, right? It should be a reflection over that. We will see. All right, y'all paying attention? This is a tricky one. Students often struggle with this. All right, first step, put the steps back up there for you. First step for finding an inverse is to replace f of x with y. All right, so I'm doing step 1. All right, place f of x with y. And then as soon as I do that, now everywhere I see x put y, everywhere I see y put x, which means this is x equals 2y plus 1. Hey, after we're done with this example, after we're done with this, let me see how much more we have. Yeah, after we're done with this, we're going to do one more example, then I'm going to give you a quiz. And it's going to be a problem like this, and you can work together on it, but it's due today. And then you can leave. You can have the rest of the day, all right? So please pay attention to what I'm doing here, all right? All right, any questions? We're good? No? Yes? No? You'll know what I'm doing? Replace that with y. Everywhere I see a y, put x. Everywhere I see x, put y. All right. What's the next thing I have to do? Still in step 1? No, sorry. Now we're in step 2, right? Solve for y. This is the hard part. This is the part that students struggle with. Getting y by itself. So what I need to do here first is clear the fractions. So I'm going to multiply both sides of this equation by y minus 1. So I multiply by y minus 1 here. I multiply by y minus 1 here. That allows this to go away, right? And on the left side, I will have y minus 1 times x equals, this will just be 2y plus 1. Now the thing that students do that's a mistake is they're like, hey, I almost have y by itself, right? So they're like, I'm going to bring 1 over and then divide by 2. But what's wrong with that? Not the x on the other side. If I'm trying to solve for y, imagine, let me write it down. I hate writing something that's wrong, but I'm going to. So a student does this. They're going to take the y minus 1 times x, and then they subtract 1 on both sides. Okay? Do y'all agree that's legal? I mean, that is legal, right? I could subtract 1 on both sides. Could I divide by 2 right now? Sure. There's nothing wrong. There's nothing wrong with me doing this. But the problem is, have you actually solved for y? Yes and no, right? I mean, is there a y by itself? Yes. But now in order to know what y is, what do you have to know? What x and y are, right? So how are you ever going to know what y is if you need to know what y is? See, y depends on itself, doesn't it? So you have not, in fact, solved for y. You've just isolated one of the y's. We don't want this. We want y equals, and everything over here is either numbers or x, okay? So what we have to do, instead of just trying to get that by itself, is we're going to distribute this x through xy minus x equals 2y plus 1. That fair? Now what I'm doing is I'm going to get everything that has a y. Every term I see that has a y, I'm going to get it to one side of the equation. Everything that does not have a y is going to go to the other side. And it's totally up to me where I put my y's. So I can either move my y's to the left or I can move my y's to the right. My call. I'm going to go to the left. So I'm going to leave this here. I'm going to move this to the other side. I'm going to move this to the left. So basically I'm going to add x on both sides. I'm going to subtract 2y on both sides. So I should get xy minus 2y equals x plus 1. Right? That's just me moving things around. Why do you think I did that? Why do you think I isolated the y stuff by itself and everything didn't have y on the other side? We have y on one side, yes. But what can I do? There's the next step. You can what? You can do what? You could divide x, but if you divide x here, you're going to have to divide x here as well, so you have an x underneath. Good try. What do these both have? Y. You have a GCF. You have a GCF, don't you? Pull it out. That's why we do this. We get all the stuff with y's over there, stuff without y over here, because that guarantees that we're going to have a GCF. Our GCF is y. Pull it out. We have x minus 2, right? Equals x plus 1. And now you can divide out the x minus 2. Divide the whole thing by x minus 2. Divide this whole thing by x minus 2. They go away here. And now do we have y by itself in terms of x on the other side? Absolutely. Oh, no, don't box that. I really want to say f inverse of x equals x plus 1 over x minus 2. That should be the inverse. It should be. That should be the function that undoes that one. Whatever this does, that one undoes it. I'm going to verify, we're going to verify it algebraically, but I'm going to verify it visually first. So here I'm going to put this into the computer. I'm going to type in x plus 1, over x minus 2. And what we should see is a function that is a reflection of the red one over that. Do y'all see that is a reflection? You'll see that? Over this diagonal, they are mirror images of one another. Okay? That makes me feel good. But I'm going to verify it. I'm going to verify it now. So that part, did y'all see the algebra in there? It was a little weird, okay? The verifying is also tricky. So pay attention to this. So I'm going to leave f there. There's f. I'm going to leave its inverse over there. And remember, we have to show two things, right? Two things to verify that these are indeed inverses. I have to show that f inverse of f of x is equal to x, and I have to show that f of f inverse of x is x. So I'm checking now. So first thing I have to check, I want to show that f inverse of f of x equals x. All right. Let's have fun. Well, I don't know if that's possible, but we'll try. I'm going to do this color coded. This was x plus 1 over x minus 2. All right. All right, let's check this first. All right. So I'm going to try and do this one. So I start out by writing f inverse of f of x. All right, what is this? Well, f inverse, right, is that function. And inside of it's going to go what? What's going inside of that? 2x plus 1 over x minus 1, right? That was it? Yeah. Right, let's make this one red. This will be. Okay, so what I'm plugging in here is I'm plugging the red one in here, right? Is this too childish for you? No? Okay, so I'm taking this blue function, I'm plugging in the red one. So I'm going to go f inverse. Okay, now let's actually put the red one. It's 2x plus 1 over x minus 1, right? So that's the f function being plugged into the blue one. Now let's actually do it, right? So now over here, everywhere I see x, right? Everywhere I see x is going to be replaced with that red one, isn't it? Which is a big ugly fraction. So I put right here 2x plus 1 over x minus 1, and then I still have next to it plus 1, don't I? That's just the top. And then below it, I have, again, x, which is 2x plus 1 over x minus 1, but now minus 2. Is that helpful, the colors, or does that make it more confusing? It's helpful? You see it? Nobody has a question? What happens?
They cancel out like a whole, right?
What do you mean cancel?
Because you have the same factor. That's all one piece.
These, you can't, I don't know if you're saying put those together or not. I don't know if that's what you're saying, but you can't do anything with these because you have long division bar. So it's kind of like if I wrote 5 plus 1 over 5 minus 2, you can't do anything like that, right? So guess what we have to do? Put those together with a common denominator. Put those together with a common denominator. And then we'll have a fraction over a fraction, then we'll do a keep dot. It's why I'm doing this problem. It's messy, all right? All right, so common denominator time. I'm going to go back to black because there's no need for colors anymore. If I put those together, then this 1, right, this 1 over 1 that was here, I'm going to have to put what on the top and bottom? X minus 1. So I'll have 2x plus 1 over x minus 1 plus x minus 1 over x minus 1. All right, over. We got to do the bottom too, right? This 2, I'm going to look at as 2 over 1. And what do I have to put on the top and bottom? The x minus 1 over x minus 1 again, right, to get a common here. So we'll have 2x plus 1 over x minus 1 minus 2 times x minus 1 over x minus 1. I don't need parentheses down there. I need parentheses on the 2 because I put an x plus 1, or sorry, x minus 1 here and here. I have to have parentheses on the top next to the 2 because it just distributes through. All right, now I can put them together. Same denominator, right? So we just add up the numerators. 2x plus 1 plus x minus 1 over x minus 1. Don't know what I'm doing there? 2x plus 1 plus x minus 1, all over the common. And then the bottom one, be careful here, 2x plus 1, be careful here. 2x plus 1, be careful here. When this distributes through, what do you get when you distribute through here? 2x minus 2, but you're subtracting that. So negative 2x plus 2. I'm showing less work because this is stuff we've done in the past, but I understand this is a tricky part. Remember, this right here is 2x minus 2, but then this negative sign is going to have to distribute through, and that's why it becomes minus and plus. And that's over what? X minus 1. What the hell's going on? Okay, where should I continue? I guess I'll continue right here. All right. So this right here becomes 2x plus 1 plus x minus 1. That's 3x. Just 3x, right? That's just 3x up there. Over the common denominator, x minus 1. And then over on the bottom, what do we get down here? 2x, take away 2x, gone. 1 plus 2, 3. 3 over x minus 1. And now if you have a fraction divided by a fraction, keep dot flip, right? So keep the top fraction. Flip the other one over. Yeah. What happens? It's multiplication now, right? That can cancel, can't it? Because it's multiplication. And you're left with 3x over 3, which is x. It checked.
It's only
One way it checked, right? We got to check the other way too. Pretty sure it's right? Yeah, we'll just trust it's right. Okay. Let's see. So the problem we did before this, what was the problem I did before? Negative 5x? Negative 5x plus 2 or something like that? That one, was it easy to solve for y? Like when we were trying to find the inverse, pretty easy? Was it easy to check? Pretty easy to check? So to me, this problem is like, this is a non-STEM problem. Non-STEM meaning these are for my algebra students who are not going on to do more math, right? This is for you guys.